Good morning, students. Welcome to physics class. Today we are going to study about the one law that is called Biot-sarvart Law. By using this particular Biot-sarvart Law, we can able to find the strength of a magnetic field due to the conductor which is carrying a current. What is the use of this particular law? You already know that when a conductor is carrying a current, around that particular conductor there is a presence of the magnetic field that is considered B. Then what is its strength? How to calculate the strength of this magnetic field? So the Biot-sarvart law is useful to find strength of magnetic field. Where we recover to find out the magnetic field here? Due to conductor which is carrying a current. Okay, current carrying conductor due to magnetic field due to conductor, or we can say in such a way that current carrying a current carrying So let us consider here is infinite length, the wire is there, a conductor. Which the length is nothing but the L. L is the the total length is. Now I am considering a small the element of this. The small element means I am considering from here to here. Okay. This is the point A, and this point is the B. This small element, the length is considered as dl. dl is the length. Through this conductor, there is a I, the current is passed through it. Okay. Let us say I. Here is a point. We consider this point as P. E is at a distance from this current element. So that the distance is So let us say R. R is the The distance. From where to where? From this point, let us call that point as C. Now we have the angle between what and what here. This dl and also the R. Let us consider this angle is theta. Okay. Consider a dl is a small element on a the conductor carrying current, that is I. The P is the any point where there is a presence of the magnetic field. I will represent that magnetic field is dB, the magnetic field. Now the theta is the angle between dl to Now let us write all these things. I is dl is the length of element. what here? Conductor. Then I is the current pass through in a conductor. dB is considered as what here? Magnetic field. R is considered as what here? The distance between what and what here? The P to what and the C. Okay. P to that is C. Now let us consider like this. This magnetic field is always directly proportional. It is always directly proportional to what here? So the length of water, the element which is carrying a what here? Current. So therefore, first and foremost thing is that, okay, the magnetic field is directly proportional to length. What that length is, that is nothing but a what here? dl, smaller element. So therefore, I can able to write like this: dB is directly proportional to what is that? dl. Now, what is the second thing? This magnetic field is directly proportional to the current. As the current goes on increases, the magnetic field is also what happens? Increases. So therefore, it is the magnetic field is directly proportional to current. Therefore, the dB is directly proportional to what I can even say? I. And it is directly proportional to the same thing. The magnetic is directly proportional to the angle between what and what here? Angle between R and also what is that? dl. dl under R. It is a sign of angle between them. So therefore, I can able to write like this: dB is directly proportional to the sine theta. Sine theta. Now it is inversely proportional to what? Inversely proportional to what I can able to say? The square of the water, the distance between them. So therefore, the fourth thing, magnetic field inversely proportional to as what here? Distance. Inversely distance. So therefore, I can say dB is inversely proportional to what is that? Square of the distance between them. Therefore, combine all these things. Okay, dB is proportional to dl, dB is proportional to I, dB is proportional to sine theta, and the dB is inversely proportional to the square of the distance between them. Therefore, on combining, what you will get? dB is equal to what? Proportional to. So here is an I. Just I will write dl into what is that? Sine theta. All are directly proportional. Divided by what is this? R square. So what is this? The proportionality sign is here. You remove this proportionality sign, then what you will get? That is K. Therefore, dB is equal to K into K is the proportionality constant. Therefore, I dl sine theta divided by what is that? R. What is this K is called? Let us come to what here? Take out this. What is this K is? The K is considered as what here? The mu naught divided by what is that? 4 pi. What is this mu naught? It is an absolute permeability of the free space. Okay. What is the meaning of this absolute permeability? That is mu naught. We have a value of this. The mu naught is equal to 4 pi into 10 to the power of what here? Minus 7. This is the value of that. So Tesla. So that the unit of this SI unit of this Tesla meter per ampere. Tesla meter per what is that? You already know that there is another unit is there for this. It is under what here? Weber per meter per ampere, or we can call it as Weber per meter per. So on substituting this to here, so what is the value of a K here? K is equal to mu naught divided by 4 pi. So mu naught value is this much, so I will substitute here. So that is 4 pi into 10 to the power of 7. So 4 pi and 4 pi is get cancelled. So what is the K value? The value of the K is nothing but what? 10 to the power of 7 Tesla meter per. So therefore, we can write this entire thing in another way as dB is equal to magnetic field is equal to mu naught divided by 4 pi into I d sine theta divided by what is that? R. So let us state the what here the Biot-sarvart law. What is the Biot-sarvart law states? The Biot-sarvart law states that a conductor carrying a current, okay, the magnetic field, strength of a magnetic field is directly proportional to the current, directly proportional to the length of that conductor, and it is directly proportional to what here? The angle, sine of an angle between the what here? DL and also what is that? R, and inversely proportional to the square of the distance. So this is what we term as a what here? The Biot-sarvart. Thank you for watching the videos. Thank you very much.